Hey, welcome back. Good to see you again. Thanks for joining the channel. Hope you all had a Merry Christmas. Hope everything went well with that way. For this special episode, I decided I wanted to do something a little special. I've had this sitting in the back burner for a long time. This is a realistic STA-2250. Now, it's kind of a unique receiver. Realistic in 1980, they released their first full digital receiver, the STA-2200, and that was 1980. 1981, they redesigned it and they came out with the STA-2250. Now this was released in 1981, and it was their all-new digital receiver. Let's see here. This was kind of a unique beast, to say the least. It's really laid out funny. It has let's go with this. So let me read out the description here. Computerized tuning convenience and accuracy plus a versatile control section. A breakthrough price. Touch a button and scan up or down the bands automatically or manually, stopping perfectly tuned at each station. With its frequency shown in a big fluorescent display, store any 16 stations in memory for instant recall. FM muting blanks out all tuning noise, and the high MPX filter cleans up weak stereo signals. The preamp has high and low filters to remove record scratch and rumble, upfront tape monitoring and dubbing controls, 11 detent bass, mid-range and treble controls, 40 detent concentric volume balance controls, stereo mono push button, and more. Fully protected against overheating and overloading. And it's UL listed. It's sold for $429.95. Now it's US dollars, 1981. It boasts 50 watts of channel from 20 to 20. Okay. So yeah, I don't know. I can't remember where this came from. It's been sitting here a long time. I think this is a electronic e-scrap rescue, and it came from e-scrap bin, I believe. It looks pretty rough. The top has some kind of staining. I hope that cleans up. Looks like it's got a big oil stain here, and this is, who knows, pretty dusty. So I think we should try plugging this thing in. Let's plug it in and check the back for DC offset, and then we'll go from there. Now this thing's laid out really odd. Most stereos have their power switch on the bottom left of the front panel. They usually have their volume control and tuning on the right. And then they have their speaker switches right after the power, and then they have their tone controls usually, and then filters, memory, everything else, and then you usually have your volume and tuning. But this thing has power on the right hand side, speaker A and B. It looks like it was laid out backwards, because usually you have your function switch on the right too. MPX filter, high filter, low filter, mono loudness, function switch. Okay, we're plugged in but shut off, and we're drawing 0.95 watts. So I guess they have a little transformer in there to keep the backup alive. I guess that's what they're doing. This wouldn't have a remote, but it would have power for the memory backup. So let's turn it on. Jumps up to about 55 watts, comes down to 25. Not hearing any click. Okay, we're on auxiliary. Let's turn the phono, FM, AM. It appears everything's working. just want to see if we have any DC. Don't know if this has a speaker relay in it. Nothing on that one. About looks like it's going up and down. Is this doing the same? This one's stable. Okay, well, let's put some speakers on it. Shut this thing off. Okay, wired in with a pair of speakers, hooked up an antenna, gave it a tone source. So let's see what this thing can do. If it does anything at all, let's turn it on. Ooh. It is working. Listen to that. Both channels. Very, very scratchy. Very dirty controls. Phono stage. You can hear the hiss, the background hiss, but some signal bleeding through. This is FM. One channel here, both channels here. That's interesting.
.750 tuyaux, 36 pédales et 3 claviers.
Look at
Aucun piston.
This thing's rocking. Picking up stereo signals. It should go up. Let's see here. Mute. I'm getting a lot. Sounds pretty good.
Yeah, for her points. If I
Yeah, so it sounds like it's working pretty good. Let's try AM. This is a nice receiver. I like this.
Traffic collision we after me.
Here's that noise. I gotta figure out what that noise is. Yeah, so it's a nice unit. It's gonna need cleaning, and it's gonna need. It sounds like one channel is weaker than the other on the left. It seems like the right channel sounds a little stronger. I wonder if I should do a test on this with a. Let's have a look inside first. Okay, just want to have a good look at this. This is probably veneer walnut. Realistic always had tried to use the real woods, not the veneer, the plastic veneers. See how dirty it is. It's got, I don't know, wheat and stuff stuck in it. It's got a big stain on this. The inside looks pretty good, but this wood needs to be cleaned, and it needs to be I think it needs a good shot of the Danish oil. I think I'm going to try that Danish oil on this. See how it comes out. Quite a bit of scratches on this side. I don't know if you can see those down here in the bottom. Not holding it very good, am I? Yeah. This side looks really dry. Let's see what we can do with the cover. Oh wow, look at this thing. This looks good. So you have your tuner all laid out here on this huge board. Looks like we have a phono stage back here with the input connectors. This is all input and tape monitor and so on, and then they have the amplifiers here. This phono power supply back here, just cased in cobwebs. Got it unplugged yet. Well, that's going to be interesting. The power amplifier comes out as a module. It's got connectors like that on the bottom too, and then you take out a couple screws and then it just comes out as a unit. Very easy to service. A little bit of microprocessor stuff happening here. Got a big Mashishita chip. It's probably running the tuning and the display. This is all vacuum fluorescent display back here. You can see there's a board, vacuum fluorescent display, there's LEDs here and more LEDs here, but there's some active components too. This is a board which just switches on it. Yeah, it's all buttons and for the tuner. Couple 6800 microfarad 50 volt caps. A nice chunky transformer too. This is a nice size. Wow, this is pretty cool. Okay, first thing it needs is a dust up. We're going to get some dust out of this thing. And I'll pull the bottom off too. Let's have a look at that. Okay, move the camera back a little. There's a lot to take in here. The cover is quite dusty. I'll clean all that out. You can see at the bottom of this board is their tone board here. And this is tape monitor and input switching. That's the bottom of our tuner, I believe. Yep. And then these are the connectors on power amplifier, one for each channel. And there's a temperature sensor there. That's probably the thermal cutout. Realistic does that. They have thermal cutouts on their heat sinks. So you can't crank them and get them to the point of meltdown because they'll kill the power. This is wiring in the primary circuit here. This goes as primary. Wiring's a mess. Connectors on all these boards. That's cool. That's really nice. The power supply's here. There's no connectors. We'll have to bring it out the bottom. Okay, I'm going to blow the dust out of this thing. There's cobwebs and dust. These look toasty. Everything else looks good. Okay, looks like I got my hands full of work to do here. This thing needs... It is going to have a full recap. These caps are done. It has... this is a power supply board, and it has all that conductive corrosive glue that's smeared all over these caps. Now, I did see one cap that was leaking. I can't find it today, but I know after I powered it up yesterday, one of these caps was leaking. I can't remember which one it was. But, you know, you've been sitting in a coma for 10, 15 years, and then somebody comes along, plugs you in, turns you on. It's bound to have a shock effect on some of these caps. They've never been powered up in maybe decades. To have full voltage on them all of a sudden. That's when they lose control and they peel over the board. And it was a fresh stain too. I can't remember where it went. I remember seeing it. So, but we're going to deal with that. We're going to do with all the caps. This power amplifier board, for example, has been worked on before because, for the most part, it's loaded with Nichicon capacitors. These light blue ones, and then here in the middle we've got 3 different types. We've got a Nippon Chemcon, we have what is this one here? It looks like a Panasonic TPO, yeah, TPO, and then we have 2 Macrons here, and some paint. Somebody's done some paint on the top of these 2. So obviously they changed these caps for whatever reason. A lot of heat here in this area and this area here from these pairs. Ooh, that feels loose. I mean, it's my imagination. But yeah, it's going to get the full cap deal. I'm thinking I also want to just clean everything. Disassemble it and clean it as well because it's quite dirty. It's been sitting in dusty. This board, for example, I can't even inspect it because it's mounted so funny. So I'm going to take this thing, probably start in the power supply first, and take that out, and then maybe phone a stage, do everything in the back. I'm going to give this thing a full recap, so I got to get busy here. It's going to be a joy to work on too. This is nice. It's a nice design, nice build. The microprocessor and everything here was working, so that should pose no problems. And it's just a matter of checking for cracked solders. I don't see any off the top of my head here because the soldering looks great on this thing. They really put a lot of effort into manufacturing these for what they are. And I was poking around on eBay looking at prices on these things, and they're going reasonably cheap. A lot of them have messed up electronics inside them, of course. That's why they're going so cheap. This one here, I plugged it in, it turned it on, and it worked fine from the start. But that can be misleading because once you, like I said, once you pull it out of a coma and shock it back to life and start using it again, all these little blue things here are going to start wanting to unload their interiors, their guts onto the board and cause corrosion. But we're going to stop that right now. We're going to pull them all out and remove all these old caps. Yeah, this will be interesting. So this power supply board comes out first. I think I'm going to desolder all these wires. I'm not going to unwrap them. I want to desolder them from the board, which would probably be quicker and faster. And then the board can come out as one unit, and I can work on it. The power amplifier is out as a unit. I can work on this easy. The tuner assembly is going to come out with the digital display portion of this is socketed on the back, on the bottom, which simplifies removal. But it comes out as a unit with the vacuum fluorescent display and the preset buttons. So that'll all come out as a unit as well, and I'll service that as a unit. The tuner will probably be staying in the chassis, but everything else will come out, including maybe the tone amplifier, input selection, and function switches will probably stay in, unless I'll probably pull these out and redo the switches. But enough of me babbling, let me get down and get to work. Okay, I went through and did the recapping, and I was checking transistors and actually found a dead transistor. 2SD-325. This is transistor 602. and it works along with where's the other transistor? Transistor 603 and 602. This is the positive and negative supply rails for tone amplifier, some parts of the tuner, and I think the phono stage. But this thing here tests like garbage. It's not even, doesn't even recognize it as a transistor. It's just, let's try this. I don't know if you can see this thing. So dim. Yeah, it just shows up as two resistors. One of them is probably a dead short. So I'm going to replace it. So, there is a zener in here too that regulates the circuit. I just want to make sure the zener's okay. So I might end up replacing the zeners too. Here's one here, 604 I think it is. It tests fine. There's another one here somewhere. This one. It tests fine too. And then there's one more here. That's fine. Yeah, the transistor is dead. Shorted. So emitter to base is shorted. Yeah, it's dead. Let's try this one. This one here. Base. It's good. It's good. This one here is PMP. It's good. And good. And good. I think that's the only defect on this board is this transistor. So I'll replace it. Probably what I'll do is I'll end up putting heat sinks on all three of these just to keep them a little cooler. Wouldn't hurt. 1.5 amps. These fuses are all right. The thing was working, so that's what I found odd. It's open? What the hell is going on here? These fuses were good. I dumped them in the ultrasonic. Maybe that destroyed them. I don't think it would, though. How could it do that? The whole board went in the ultrasonic, so the receiver was working. How can this not be working? That is weird. And there's the filament looks good. I can see the filament in there. It's all right. Wow. Looks like I found another one. This joint here, and this is the emitter resistor for this channel. This is the right channel. This emitter joint here is totally cracked and disconnected. Now this is a manufacturer defect, but I don't know how long it's been cracked. I'm just going to push it through and it won't let me. Maybe just try it with a soldering iron. There we go. I pushed it through. See it there now? Wiggling. Let's solder this one up and then it won't be a problem anymore. I wonder if that was a noise I was hearing in the one channel. Alright, everything else looks good. New caps. And I'm going to check some of these transistors. Especially these ones that are heating up pretty good. I want to make sure that they're okay. Don't want to have any failures after I put this in service. So, alrighty, this one's done. So I did everything I needed to do on this. I treated the pots. Still have to clean the back a little bit more. Did a full recap. This is where you're going to find most of your gains from doing a recap. This realistic tone amplifier is kind of rudimentary. You know, you look at some of the manufacturers, they have full complementary output, they have a differential pair at the input, and they have feedback with integrated into the feedback loop, the tone controls. And this thing is just not built up to that kind of a spec. It has all these blocking capacitors in between each stage, and they had all these low value electrolytics. So over time these drift and change in value quite a bit. I was measuring 25% drift in the tolerance on a lot of these caps. Most of them around 15%. But when you take them all out, all those garbage caps, those old ones, and put in nice film caps that are consistent and they're equal in value and they're stable, they're not going to change, to me it makes a big difference in the sound, especially when you compare one channel to the other. When you have an old receiver, old caps that drift in value, your channels don't match in sound quality anymore. They have different sound signatures, let's say. But when you take all those old caps out, put in fresh new ones in that are pretty much equal in value, they're all pretty close in tolerance. It makes a difference to me, anyways. I can hear a difference. Not in all cases. I'm not saying I have magic ears, but sometimes I do hear a dramatic difference when you pull out old caps and put new ones in. And this tone amplifier is where you're going to get your biggest gains. That's what I'm trying to tell you, because it had the most capacitors in the audio path that were taken out and replaced with film. A lot of these low values were film. Like these are 0.47s, these are 2.2 microfarads, a couple of ones over here, and then there's these 4.7s that I replaced with audio grade 3.3s, same thing. And then the power filter caps, well, they've gone down in size too. So this is ready to go back in. Next up is the microprocessor control. I've done this board too, recapped it, and that's all I've done to this, is just a recap. And this one needs a clean. You can see it's pretty dirty. Alright, so I found another defect. This is a wire that's pinched. It was pinched under the bottom plate in this strut here, and it's all crushed. And it looked like it was shorted. Pinched right through. And this white wire, if I follow it, goes to the power supply, comes out down here on this pin right here, which equates to pin 8 on this board. Pin 8 on this board goes directly to the emitter of the dead transistor I found. So it makes kind of sense that that line was shorted to ground, this transistor blew. I'm really surprised this thing was working when I powered it up. But that was from the factory like that. Or maybe not, maybe somebody had it open and closed it up again and pinched the wire. But yeah, that transistor was dead. And replaced it, so we're all good now. Also, this pink wire was pinched. You can really see it, it's kind of flattened here. But it didn't break through the insulation. It just kind of caught it on the edge. This is a speaker terminal wire. It goes up to the speaker switch. So I'm assuming it was pink wire. I don't know where it comes from or where it goes. But I could follow it back. It probably goes to speaker terminals. Let's see here. It goes up to the B speakers, left channel. So that's what that is. But yeah, that's something you got to watch for when you're putting things together. You don't want to pinch any wires. What I'm going to do here is just remove the wood sides. I've got 6 screws, and they are short wood screws like this. So I'm just going to remove all these screws, separate the sides from the lid, and I'm going to clean them separately. And treat the sides with Danish oil, and the top gets cleaned with some kind of cleaner. It looks pretty dirty. Okay, so I'm just going to apply this stuff. Antique Danish oil. Circa 1850, is that the brand name? It's an oil varnish. And it does have a solvent in it, so it's flammable, it stinks up the room, yes. And then once the solvent evaporates, it leaves the oil behind, which has a different smell. Kind of a, I don't know, it's not a very pleasant smell. So I like doing this several weeks before I need to return it back to a customer, because it has to have time to air out, and it does off gas and stink when it does its airing out business. Okay, so we're just going to apply some on this one, and you notice how some of the scratches will disappear. Quite a bit. It's very dry. I'm going to do the edges as well. Here's some paint. Okay. Paint on there. And this is the front. Okay. Soak into the big gouge here. Don't need to do the bottom. Okay, let's. So already you can see there's going to be quite a difference between the two, where I treat it and untreat it. And just rub in a layer, and that's all you really need to do, is that amount, and it'll dry. Here's the untreated stuff. That's what it looks like. So you put them together and see a difference between the two. And this will brighten it up quite a bit. Get rid of some of these scratches down here. See, they just disappear. So let me get some more on here. It's a good thing that Radio Shack used real walnut veneer on their receivers. I like that. Gives them a nice touch. Probably should have cleaned this first, but I think it wasn't really dirty to begin with. It was just really dry. Okay. Now, I'm just going to let that sit and let the solvents evaporate, and then I'll have a look at it. I might do a second coat. It looked pretty bad when I started, but I think this will help quite a bit. Alright, here's a look at the cover. It looks pretty dirty, as you can see. It's got baked in dirt. It's got like an oil stain on the front. And it has, looks like pine needles in here as well, underneath the dig these out manually, because it's really Not a good look. So what I'm going to use is I'm going to use spray 409. It's a bit caustic, but it will clean all this crap out. The thing is, this has kind of got a pebble finish to it, and if you just use cleaner, it cleans the surface, but all the stuff that's embedded in the pebble finish won't come up. But the spray 409, it seems to get in there and it lifts the dirt out, and you scrub it with a brush, and we'll see how this looks after I'm done. Okay, here it is next day, and these have had time to dry, and they look a lot better than when they came in. Still pretty beat up on the bottom edge here, but it's still a huge improvement over what I started with. So I'll put that aside. And the top is looking great too. Gave it a good scrub, and it came back really clean looking. I think this is a vinyl wrap. Pretty sure it is. It has a vinyl coating on it. So these you can scrub down, and that's exactly what I did. Got a lot of the dirt out of the valleys, because it's a rough surface, texture surface. Yeah, this is looking really nice. A lot better than what it was. The screen mesh here, I might glue some of this back down because it is popped off. Yeah, you know what? It's fine. It's holding up. I'll just leave it. But happy with that. I'm going to put this together now. So don't go crazy on the torque. These are just little wooden screws into plywood. They're only about a 1/2 inch long, not even a 1/2 inch. Just very lightly torque them down. If you do strip one out and it just starts spinning, you have a spare hole here. You can punch another screw beside it. That's why they have these extra holes. If one of these holes gets stripped out, you can use the one next to it. Just very light torque. Alright, I ran into a problem when I powered this thing up for the first time. Had a fault where the tuner would not work at all. I'll show you what it was doing. Now, it was quite a... let's see, I'll just turn it on and show you. So, I turn it on, and it shows AM 777 kilohertz. And if I switch it between AM and FM, it does not change. It's very mysterious, and none of the buttons work. If I try any of the buttons for scan or memory, nothing works. Nothing. Try it on AM, absolutely nothing works. So, I'm thinking to myself, what did I screw up now? Now, this board, this is the processor board for the tuner, the computer controlled. There's a big chip on here. I thought maybe when putting it in the ultrasonic screwed it up. I thought, okay, maybe it destroyed the crystal, or maybe the crystal was picking up the vibrations from the ultrasonic bath and inducing a voltage into the chip, which destroyed the chip. And I was thinking all these different scenarios, and I was thinking, what's going on here? But I'll tell you what I found. So what I started doing is I started checking voltages. First I checked the voltage on this 8-volt regulator. It was there, and there's a 5-volt here. So these two voltage regulators were working and providing current. I checked the power supply on the receiver, and it was working fine too. Tested test point 801 and test point, where's 802? Another test point here somewhere. Can't find it right now. Where did it go? Oh, 802 right here. One of them had a carrier frequency, one of them had data. And so this chip was working. I could see when I first clicked it on, there was spikes of data going on one of these, this one here I believe. So what I did is I took my multimeter, put it in diode mode, and connected one lead to ground, and I started checking each pin for any shorts to ground. I was looking for that 0.6 volt diode drop and all these, and I was getting a diode drop of 1.4 volts or 1.2 volts or whatever. So all these pins were checking out. Now all of these pins are assumed okay because it's making a display, right? We were getting a display of 777. That's working. So I'm not going to focus my attention on the outputs. I was looking at the inputs here, and I went through and checked all these. These were all fine until I hit pin 19, and it showed it a 0 ohm short to ground. And I was like, what the hell? I checked the traces, and everything was fine. And then I started looking at these components here. There shouldn't be a short to ground with, we have a capacitor hanging off it going to ground, and we have a germanium diode hanging off it going to ground. So I checked these two components. I actually removed them from the circuit, pulled this cap out, tested it. Ceramic cap, it was around 12 or 13 nanofarads. Okay, a little bit high. I don't know, maybe the trip to the ultrasonic bath damaged that cap, I don't know. So I replaced it with a mylar film, 10 nanofarad. And then I looked at this diode, and this diode was open, completely open. I think it was damaged in the ultrasonic bath, to tell you the truth. It was a glass germanium diode, and maybe the vibrations killed it. I don't know. This diode was fine. Here's the bulk capacitor for storing the memory backup charge, the 4700 at 10 volts. This capacitor charges up, and then it supplies an hour or two of power to hold the memory. So open diode, yeah. So I replaced that diode, and it started working. Here, I'll show you. Okay, so here's diode 806, and I had it removed from the circuit just to demonstrate what the tuner was doing with it open. So I'm going to put this back in circuit, and we're going to solder this back in, and then I'll show you again how it's working. If I can get this. And this is the cap I replaced, this green one here. This is the 10 nanofarad. I put in a mylar film. Okay, I'll solder this down, and then I'll demonstrate again. Okay, here it is. I got the board reinstalled. The diode is soldered back into the circuit. Let's try this again. Turn it back on. And we have our tuning working. Let's see if we have FM. FM's working. Memory buttons are working. Everything's working now. There's our memory. You can't see that right here. There's a memory lamp. So, yeah, I'm pleased with this. So, don't put germanium diodes in the ultrasonic cleaner, I guess. That's the lesson to learn here. Okay, I got no service manual or instructions as to how to set this amplifier up, but I've got it connected across both emitters. And if I look on the schematic, across both emitters puts us across both emitter resistors. 0.5 ohm, 0.5 ohm times 2. So what I'm reading is 100 millivolts and climbing. It keeps going up. Here's the power consumption, 41 watts. I think 105, 106 millivolts is way too high. So let's turn this down. Let's turn it down to closer to 50, 40 or 50. Let's take it down to 40 right now. And you see our power consumption dropped to about 35 watts. Let me get set up on the other channel. There is a post there to tie to. I'm just going straight to the emitters on the transistors. So let me swap my leads, power down and swap my leads, and then we'll come back. Okay, I'm on the other channel here. I'm just going to turn it on, let it warm up for a bit. It seems it wants to climb right up there, so it's going to turn this down. Well, it's turning it up. Turn it down this way. So right about there, 27 watts consumption. I'm going to let this cook for a while and see how it stabilizes. Alright, so I adjusted both channels to about the 35-40 millivolt level on the bias, and we have for consumption here 28 watts, 29 watts, which is Sounds normal to me. So let's get a power test going here. Alright, let's do our power test and see how this thing works. Got everything connected, I believe. Let's turn it on. Turn it on. There's speakers. Let's get an auxiliary. Here's our tone. That's weird. Oh, that's still scratchy. I thought I cleaned it up. Okay, anyways. Shut that off and let's turn this up. Okay. Yeah, it's quite scratchy on that one channel. Here's clipping. This volume pot's messed up. See, turning up and down here, see how that works? Look at the right channel's working, but the left, it's got some slop in it. I have to go and fix that. The pot is sticky. Anyways, let's try and get some. Okay. Wow. Let's turn it up here. Okay, there's clipping on the top one. That's the one I'm going to measure. So I'll turn it down. Turn it down right to there. 24.25 volts. And we'll see how this goes along here. We're at the 6-minute mark here. The heat sink's just starting to warm up. It's about 50 degrees C. But we're still cooking. Power dropped by a little bit, but I think that's just from the heat. Okay, coming up to the 10-minute mark. So our power consumption's right at 257 watts and holding steady. Our power output dropped a little bit. We're down to 24.06 volts RMS, so it dropped a little bit. I just want to check this heatsink feels like it's around 60 degrees C, and I'm getting 57. 59, yeah, right around 59 is about the peak I'm getting. So let's turn this down. I think it proved its point. So let's turn this down and let's look at some square waves. Okay. Look at that volume control, how it's working. It's got some slop in it. I'm going to have to go in and open that up again. They're not tracking together. Okay. Let's get rid of this. Sounds like we got a dodgy switch here too. This one here in the center. Take these switches apart and clean them. They are not behaving well. Okay. Okay, so this is the high filter, and this is the low filter. Mono. Mono makes no difference on the signals coming through. Loudness. Okay, there's your loudness. So bass cut. What the hell was that? Bass cut. Bass boost. Somewhere in the center here. I don't have a knob on it. Mid-range cut. Mid-range boost. Treble cut. Treble boost. Okay. Yeah, we're not looking very good on this one amplifier. It's not balanced. Alright, let's go up in frequency and see how bad this thing really is. So we're at 1 kilohertz now. Let's go up to 5 kilohertz. Not too bad, I guess. 10 kilohertz. 10. Let's keep going. Right about here, it looks like we're losing our, really losing our square wave here. And this is only at 21 kilohertz. Okay. Just want to go through. Starting to shrink right about here, 39 kilohertz. So we're losing our highs. I think there's some artificial coloration going on here. That is 100 hertz square wave. Cut the bass. Here's mid-range cut. Looks like it's adding distortion. Mid-range boost. Treble cut. Treble boost. Not the best tone circuits in the planet. Anyhow, I think I got a good idea. All right. Let me finish putting this thing together, and then we'll do a final listen. Okay, a little update here. Putting it back together. I did have the service manual for this. I just had it in the wrong folder and I didn't find it. But it has procedures for setting up the bias, and they want 10 millivolts across one of the emitter resistors, so 20 millivolts across both. I wasn't far off, but the way it was set up before, it was over 100 millivolts and climbing, so it was over 50 millivolts for each resistor, but that wasn't right. So I'm going to reset the bias down to the specified level. I also took these switches out and de-auxed the crap out of them, and they should perform a little better. They weren't bad, but they were a little scratchy, a little iffy. And if they still pose a problem, I can yank this out and replace these switches. These are really common switches, so you can find these. and replace them. Other than that, it's complete. I think everything else is done. Just putting it back together, and then we'll give it a final test. Well, there it is, all back together, and I think it looks great. I love the wood sides, black top. Gives it a nice look. And the top came out not too bad. It's got some abrasions on it. Really nothing you can do about that, but cleaning it makes a world of difference. It gives it a new look. Very nice. Okay, let's try this out. Let's go for FM. Let's see what we can do here. So let's start from the bottom of the band, work our way up, see what kind of FM reception we get out of this thing.
The airport, make sure you're looking really good.
Getting good signal strength on all the stations. These are fairly weak stations to begin with here. Getting also a lot of noise too on my bench. It's having a hard time with all the noise. Keep skipping this station.
34 bi-weekly. Watch, spin, and win.
City Board will beat any bona fide price.
What do I have on that's making
on the
noise?
spot during our famous Boxing Week special.
It's coming in loud and clear.
Merry Christmas, movie listeners.
I love the holidays.
Okay, so that wraps this one up. I'm going to, going to have this one, listen to this one for a while. I like this. I like the large display. I love that. It's something you can see from across the room, which is the way it should be. Not with these little tiny displays you can't read. You have to step up close to them to see what they are. Lessons learned. Don't put glass fuses and don't put germanium diodes in the ultrasonic cleaner, I guess, because that destroys them. Aside from that, everything went well. I had, let's see, I had found one fault. I think it was a factory fault, to tell you the truth, with that shorted power supply line. It was crushed and it was shorted to ground, and it blew that transistor in the power supply. It's surprised it worked, but it's working now just as well. So I'm going to wrap this up and call our quits on this one. I'm going to enjoy listening to it. Now for the bad news. For the next few weeks, or 3 weeks, 4 weeks anyways, I'm going to be taking a break. I'm not going to be posting videos. I got some stuff to get caught up on around here. I got some cleaning up to do, some sorting, some general maintenance. I got some work to do. The mother-in-law's car, the transmission's acting up, and she wants me to look at it and help her with that, so I'm going to spend some time on that. I'm going to be doing a lot of things outside of restorations and repairs on audio equipment or electronics. So like I said, I'm going to take a break, so you probably won't see a video for a few weeks. I do have a couple videos in the can that I could post from last month that I could put up if you guys are in heavy withdrawal. But until then, I'm going to have a break. So I'm not going to see you again. Have a Happy New Year, and I'll wish you all the best for 2024. And looking forward to producing more content in the new year. So take care. I hope you're all well. And thanks for watching.